In this lesson, we're going to learn how to multiply and divide rational expressions. Really, we're just dealing with fractions here, so when we multiply and divide, we're going to follow the basic principles of multiplying and dividing fractions. Here we have a multiplication problem. We have 3x squared plus 3x over x squared plus x minus 6 times x squared minus x minus 12 over x squared minus 3x minus 4. Now, we saw in the previous review that when we multiply fractions, we multiply straight across. So some of you might already be working on this problem thinking, okay, I'm just going to go through and I'm going to distribute everything, but that's actually going to make the problem more difficult. If you remember the first multiplication example that we did, we ended up simplifying it at the very end. If possible, you can actually simplify it in the beginning also. So what we want to do here is we actually want to factor everything. We're going to factor the top, we're going to factor the bottom, we're going to factor everything, because if we're just going to end up multiplying all this stuff together and simplifying it at the end anyway, we're looking for things that might cancel out. So let's take this first fraction and simplify the top. So on top, notice there's only two terms. I see that they both have a 3, and I also see that they both have an x. So we're going to take out the GCF here. We're going to factor out a 3x, which if I factor out a 3x, that would leave behind x plus 1. And we're going to do the same thing on the bottom. We're going to take this and we're going to factor it. I notice that there are 3 terms here, so I'm asking myself what multiplies to negative 6 and adds up to 1 in the middle. So I'm going to have x times x to get that x squared, but then what multiplies to negative 6 and adds up to 1? That would be a positive 3 and a negative 2. Okay, so I factored my first one. I'm going to come to the other side and I'm going to do the same thing. I'm going to factor the top and the bottom. So on the top, I have 3 terms. I know that I need an x times an x to get that x squared, but I'm asking myself here, what multiplies to negative 12 and adds up to negative 1 in the middle? That would be negative 4 and positive 3. And then on the bottom, again, I have 3 terms. I know that an x times x will give me that x squared, but for the other numbers, I need to know what multiplies to negative 4 and adds up to negative 3 in the middle. So that would be a negative 4 and a positive 1. Okay, so we've factored everything. And now we can start looking at the top and the bottom. Remember that anything divided by itself is going to cancel out. And if we are multiplying this together, think of it as one giant fraction. Anything anywhere on the top can cancel out with anything anywhere on the bottom. So I'm seeing over here an x minus 4 on top and an x minus 4 on bottom. That's going to cancel out. I also notice an x plus 1 on the bottom and an x plus 1 on the top. Even though they were in different fractions, remember you're multiplying all this stuff together, so really anything across the top and anything across the bottom can cancel. I see one more over here. I've got an x plus 3 on the top, and I've got an x plus 3 on the bottom. So that's going to leave me with, across the top, I just see a 3x is all that I have left on the top, and on the bottom, all I have left is an x minus 2. And that is my final answer. I actually didn't even have to do any multiplying. We just factored everything and enough stuff canceled out that there wasn't anything left that needed to be multiplied. All right, let's try a division problem. So remember that when you divide fractions, you are going to multiply by the reciprocal. That just means keep it, change it, flip it. So the very first thing I'm going to do with this problem is I am going to rewrite it. So I'm going to rewrite the first one. Remember, I'm going to keep this first fraction exactly the same. So x squared minus 9 over x squared plus 2x. And then I'm going to change it. Instead of a division problem, I'm changing it to a multiplication problem. And then flip the second fraction. So now the x squared minus x minus 6 is going to be on top, and the x squared plus 2x minus 3 is going to be on the bottom. So now now I've turned this thing into a multiplication problem. We're really going to treat it exactly the same as we did the previous one. So I know if I'm going to end up multiplying all this stuff together and then simplifying in the end, I might as well see if there's anything that could be simplified now. So I'm going to bring all of this stuff over, but I'm going to factor it. So I'm looking at the top of this first fraction here, x squared minus 9. As soon as you see that 9, you should be thinking difference of squares. I know the square root of 9 is 3, so the difference of squares is going to be x plus 3 times x minus 3 for the top. On the bottom, I've got x squared plus 2x. Now, these are not perfect squares, and we only have 2 terms here, so I'm looking at those 2 terms thinking, what do they have in common? And I noticed that they both have an x, so I'm going to factor out a GCF. I'm going to bring an x to the front, which would leave behind x plus 2. Now, the second fraction, I'm looking at the top here. I have 3 terms. I know that x times x is going to give me that x squared, but the other numbers, I need something that's going to multiply to negative 6 and add up to a negative 1 in the middle. So that would be a negative 3 and a positive 2. Same thing on the bottom. I have 3 terms, so I know I need an x times x to get that x squared. And then I'm looking for what multiplies to negative 3 and adds up to positive 2. So that would be x minus 3 and x plus 1. So now this is a multiplication problem, but I know I have to simplify, so I'm going to look for anything and everything that could be simplified right now. Fun part, we get to cancel stuff out. Let's see, I see an x minus 3 on top and an x minus 3 on the bottom. I see an x plus 2 on the top and an x plus 2 on the bottom. And that looks like it. So here's what we have left on the top. On top we have x plus 3 times x minus 3. And on the bottom, we have this x left times x plus 1. Now, you can either leave your answer just like this in factored form, or if you want to, you can actually multiply this stuff back together. So if I were to multiply this together on top, I would end up with x squared minus 9. And if I were to multiply it back together on the bottom, I would end up with x squared plus 1x. Either of these would be a fine way to write your final answer. Let's try one more division problem. So here we have a division problem. So we're going to follow the principle, change it, flip it. So I am going to keep this first fraction exactly how it is. So x squared plus 4x over x squared minus 2x minus 24. And then I'm going to change it to multiplication. And I'm going to flip the last fraction. So 6 minus x on top and a 2x on the bottom. Now, as we did in the 2 previous examples, once you get here, instead of just multiplying anything and everything together, instead, we want to factor it and we want to look for anything that could be simplified up front. So for example, the first fraction, if you look at the top, there's only 2 terms. I noticed that they both have an x. So I'm going to take out the GCF. I'm going to put that x in the front, which would leave behind x plus 4. On the bottom, we have 3 terms. I know that I would need an x times an x in order to get that x squared. But then I'm looking for what multiplies to negative 24 and adds up to negative 2. See, that would be an x minus 6 and x plus 4. Now you might already be seeing things that'll cancel out, and in fact this x minus 6 looks awfully similar to the 6 minus x that we see on the other fraction, but those are not exactly the same. In fact, 6 minus x is really a funny way of writing things. Usually we put the x first, right? So if I were to write this in the correct order, this would be negative x plus 6. So that clearly doesn't match the x minus 6 in the other fraction. But if you take out a GCF, in fact, if you think of this as a negative 1, we can factor out a negative 1. So if you divide by negative 1 right here, that would become a positive x minus 6 on top. Okay, that's kind of a quirky one. And then on the bottom, 2x, you could think about that as 2 times x. So it could be broken up in that way, 2 times x. All right, so let's look for anything and everything that's going to cancel out. All right, we see the x plus 4 on the bottom. That's going to cancel out. We have the x minus 6 on the top and the x minus 6 on the bottom. That's going to cancel out. I also have just a single x up here and a single x on the bottom. That's going to cancel out. So that actually leaves us with not very much to work with. Across the top, all that's left is a negative 1, and across the bottom, all that's left is a 2. So my final answer is negative 1/2. All right, that's our last example for multiplying and dividing. If you need to rewind the video or re-watch any parts of it, feel free to do so, and then get started on your Delta Math assignment.